Hello everyone, my name is Lorianne Sutman, and the topic I've chosen for this project is Theaetetus's The Five Platonic Solids. The Platonic solids, also known as cosmic figures, are regular polyhedra, which means many faces. Only 5 Platonic solids are possible. We'll talk a little bit about why later. They are characterized by the fact that each face is a regular polygon and all of their faces are congruent with one another. The Platonic solids get their name after the Greek mathematician Plato. He was impressed by the 5 definite shapes that constitute the only perfectly symmetrical arrangements of a set of points in space. He explained a complete theory of everything based on these 5 solids. Plato concluded that the Platonic solids must be the fundamental building blocks, the atoms, if you will, of the universe. He assigned each of them an essential element of nature: fire, earth, water, air, and the universe. So let's look at each of the Platonic solids a little bit closer. The first of the Platonic solids is the tetrahedron, composed of 4 triangular faces symbolizing the element of fire due to the heat of fire feeling sharp and stabbing, therefore should be handled with care. Next we have the hexahedron, or cubed as it's better known, composed of 6 square faces, representing the element of earth because of its solid foundation and stability. The third Platonic solid is the octahedron, which is composed of 8 triangular faces symbolizing the element of air, meaning its minuscule which is composed of 8 triangular faces symbolizing the element of air, meaning its minuscule components are so smooth one can barely feel it. Then we have the dodecahedron, composed of 12 pentagonal faces symbolizing the universe because of its framework for the descending subtle energies of the spirit. The fifth and final Platonic solid is the isohedron, composed of 20 triangular faces which symbolize the element of water for its willingness to allow others to assist in a situation. Kind of like how we say, go with the flow. Theaetetus wrote the first complete account of the 5 regular solids. He knew to achieve perfect symmetry between the vertices of all the solids that each face of a regular polyhedron must be a regular polygon, and that all the faces must be identical. So Theaetetus started by considering what solids could be constructed with only equilateral triangles. This is how he ended up with the tetrahedron, octahedron, and isohedron. All of these solids are equilateral triangle faces, varying from 4 to 8 to 20 faces. Any other number of faces would not result in a finite solid. They would either have infinite radiuses or they wouldn't have the same number of vertices at each point. Theaetetus also found only one solid using square faces, the hexahedron, consisting of 6 square faces, and the solid must have 3 vertices at each point, otherwise Theaetetus would have ended up with another infinite solid. It would have gone on and on and on. Theaetetus finally composed the dodecahedron, which is made up of 12 identical pentagons. Like the other Platonic solids, it's not possible. Why does that keep popping up? It's not possible for the pentagons to create a larger solid with more faces because we would end up with an infinitely large solid. So we've talked about the contributions Theaetetus and Plato have made in the discovery of the Platonic solids. Now we have one more individual to discuss that's contributed to these solids, and his name is Euclid, and he is the author of Elements. Euclid devoted the 13th and final book in Elements to the properties of the Platonic solids. In Proposition 18, Euclid writes a proof that determines only 5 of the regular polyhedra are possible based on the rules set for the solids. These rules include, but are not limited to, each vertex of the solid must be formed by joining 3 or more faces. The sum of the angles formed by these faces at the vertex must be less than 360 degrees. Note that if it was exactly 360 degrees, the solid would be flat, and if it was more than 360 degrees, the faces could not be joined. Because the angles of all vertices of all the faces of the Platonic solids are identical, at least 3 faces are joined at the vertex. The size of the angle of each face must be less than 120 degrees. Using Theaetetus's knowledge of the Platonic solids, Euclid was able to write these rules based on his proof. So why is all this important, and why are these Platonic solids significant to us? Well, the ancient Greeks have always thought of geometry as an important topic. Plato himself said, "Let no one destitute of geometry enter my doors," meaning he wanted no one ignorant of geometry to enter his doors at the academy. These solids have many significances other than their advancements to the field of geometry. One being, for the ancient Greeks, these Platonic solids were seen as art. As for the Greeks, geometry played a large part in art, as they used them for references in painting, sculpting, etc. Another example of these Platonic solids are the significance being they believed to constitute the building blocks of the entire physical universe, as Plato had thought in the beginning of this presentation. The idea that they are the building blocks of the universe is proven by Kepler's fundamental discoveries in astronomy, and were directly inspired by the Pythagorean Platonic ideas about cosmic significance of geometry. Another place we see the Platonic solids in today's sciences are in viruses like herpes virus, which is shaped like the isohedron. So these are the references I used for this presentation, and I hope that you learned something new about the Platonic solids in the last 8 minutes. I know I learned a lot preparing for it, and I